So our next exercise involves finding a possible formula for a given graph. This is the graph of a polynomial function that we see here. And I guess the thing that you want to observe first is that we know a lot about the zeros, right? The x-intercept values here for this function. In fact, there's a whole bunch of x-intercepts, 1, 2, 3, 4, 5. So we have zeros, using that new vocabulary word. We have zeros at x equals -2, -1, 1, 2, and 3. So that means our function is going to have factors that look like x plus 2, x plus 1 for the two negative factors, x minus 1, x minus 2, x minus 3. It's going to be a 1, 2, 3, 4, 5, fifth degree polynomial. And there's like a twist to this now. This is something we haven't seen yet. In coming up with this formula, we also have to consider a possible value for the lead coefficient, which is like a constant factor. I'm just going to write an A here for that we can multiply this entire expression by. So I'm not going to multiply this all out, but so far I almost got my answer, right? I'm just going to try to highlight this a little bit. But we need to determine the value of A. So just knowing that we have all these zeros still leaves us with more than one possibility for this constant A. What we do know, though, is we have a y-intercept at the point 0, 4. So that means that f of 0 for this function has to equal 4. That's the only point we know that's not actually a x-intercept. And so what I'm going to do is I'm going to take what we have so far, and I'm going to plug in 0, so I get a times 0 plus 2, 0 plus 1, 0 minus 1, 0 minus 2, 0 minus 3. And of course this can be simplified a whole bunch, right? This is a times 2 times 1 is 2 times -1 is -2 times -2 is +4 times -3 is -12. And that f of 0 has to come out to be 4. So we can solve this little equation. We have, I'll write it over here, 4 equals -12a. So 4 over -12 is a. That means that reduces to -1/3 is a. So my final form of this function here is f of x equals -1/3 times, here come all the factors, x plus 2, x plus 1, x minus 1, x minus 2, x minus 3. And there's my final answer. Okay. So maybe I should put right around that to make it stand out more. There's our final result. Now exercise 3, find a possible formula for this one. It's the same kind of thing now. I see that we have zeros at x equals -1, x equals 3. And what you got to notice here is they have multiplicity 2. In fact, both of them have multiplicity 2, right? That means that those factors have to occur squared. I guess they could conceivably have multiplicity 4 or 6 or 8, but we want to keep this as simple as possible. So our function is going to have x plus 1 factor squared and an x minus 3 factor squared. So here's where multiplicity comes into play. We know that we have this even multiplicity because the graph does not cross the x-axis at those zeros. And then we have to introduce our constant a, and we got to solve for a. We got to find a value for a. We can use the y-intercept, again, which is 0, 2. So f of 0 is equal to a times 0 plus 1 squared times 0 minus 3 squared. That f of 0 would have to be equal to 2. 2 equals a times 1 times 9, correct? 2 is 9a. So 2/9 is a. And I think I got my formula for this one. F of x is equal to 2/9 times x plus 1 squared times x minus 3 squared. Okay, and so there was our first problem, exercise 2 for this section, with the answer kind of squeezed in there, and exercise 3 with its answer.